Our PowerPoint presentation is on radioactive decay and dating by Ashley Lane Beneke and
Anna Rose Templeton. What is radioactive decay? Radioactive decay, also known as nuclear decay or radioactivity, is the process by which a nucleus of an unstable atom loses energy by emitting particles of ionizing radiation. A material that spontaneously emits this kind of radiation, which includes the emission of energetic alpha particles, beta particles, and gamma rays, is considered radioactive.
It's very hazardous, so don't get around radioactive decay. How it happens, you ask? Well, the World State of Physics says that radioactive decay is a very random process and therefore cannot be predictive. A radioactive element exhibits fewer decay per units of time at an exponential rate. Radioactive decay obeys the conservation of mass and other various laws of conservation. Can it be found in nature or created? Yes, it can. It can be both. The first scientists that studied naturally occurring radioactive decay was Mary Curie and Antonio Harry Becquerel. They both won the Nobel Prize for their studies on spontaneous radioactivity. The scientists found that the radioactive decay in substances such as uranium, radium, thorium, and polonium. Oh, there's several different types of radioactive decay, including alpha decay, beta decay, and gamma decay, and they're classified by the type of particles they emit. So, radioactive decay has many medical technologies, such as nuclear power and nuclear weapons.
These are pictures. This picture is the alpha particle in alpha decay. This is beta decay, and this is gamma decay. And so you can just look at that and tell what they're doing.
Exactly. You can see how they react to different particles and how they react to different gases.
What is radioactive dating? Radioactive dating is the technique of comparing the abundance radio of a radioactive isotope to a reference isotope to determine the age of a material. It's called radioactive dating.
And right here, this is a picture of what radioactive dating looks like. It kind of shows you different elements that have been taken throughout the years and how they're decomposing underneath the earth. How it works? From the Guide to Nuclear Wall Chart says that once a living thing dies, they can't exchange carbon with the environment anymore. So this isotope called C14, which is radioactive and beta decays with a half-life of 5,730 years, they all come together, and it kind of creates a chemical reaction so that the once living thing starts to decompose. So this means that 5,730 years, only the half-life of C14 will remain. And after 11,460 years, only 1/4 of the 416 remains. For example, there was an Iceman that they found. He once lived in the Alps, and he died and was entombed in a glacier until recently. They found him because of, I think it was because of what's it called? The world's heating up.
Global warming?
Global warming. And so the Alps are starting to melt. So they found his body, and the man's body was recovered, and pieces of tissues were studied, and they still had their 14C content by accelerated mass. And the body was estimated by radioactive dating to, they say he probably lived between 3350 and 3300 BC. Wow. That's pretty cool. That was a long time ago.
Woo!
Your turn.
Radioactive dating and non-living things. How it works. According to the article Radioactive Dating published on howthingswork.com, 40K decays with a half-life of 1.3 times 10 to the 9th years to 40 AR, which can be trapped in rocks. Radioactive dating has helped scientists learn the approximate age of Earth and galaxy. Whoa, man.
That's pretty cool. I mean, I didn't know how old the Earth was until I did this project.
Gotta
what about
love
you,
physics.
Anna Rose?
I agree.
Physics is so great.
I know. You just learn something new every time.
Of course.
For example, Using the decays of uranium and thorium, our galaxy has been found to be between 10 and 20 billion years old.
Wow.
I know.
That's pretty old.
I know. I can't imagine that. Like, 18 years seems like a while.
Wow. I wonder if people lived then.
I hope not.
Me too.
They
That
get
was
eaten
a
by
long
dinosaurs.
time ago. Oh, right. The dinosaurs. I forgot about those.
Yeah. We gotta watch out for them.
Ooh.
Back to physics. The Earth has been found to be 4.6 billion years old. Hashtag radioactive dating.
Yay.
I went there.
Okay, so here's some examples of how radioactive decay in non-living things has happened. Sorry, we're going back to radioactive decay and radioactive dating.
We just love
But
them both.
they're just great topics. So you kind of see what's happening in this. You see that the half-lives and like what they go through, and these are non-living things. So you kind of see how they're like decomposing and what's happening over them through the radioactive dating and decaying process. So let's just take a look at this for a while. I mean, it's pretty fascinating. Do you have anything to say about that, Anna Rose?
I mean, it just looks awesome. Like, woo!
Woo! Go physics!
Radioactive decay.
Yeah. And we just want to talk about this for a little while.
Okay.
So let's just go over. That was our PowerPoint. But you know, there's so many other things that is great about physics. For instance, this really cool website right here. We're going to tell you some more about radioactive dating.
Yeah, you can literally just Google something and something pops up, and then you can just know all about anything in physics. So even when you stop teaching us, we'll still get to learn more.
Yes. Okay, I kind of want to go back to this picture for a second. Right there.
Oh, that's good.
That shows you a radioactive nuclei. This is very interesting because the nuclei is emitting rays, and that's very fascinating. And this is kind of how it works, and this really just kind of sums up radioactive decay in a particle, well, a nuclei, really well. So that's what's going on there. And then here's another example of radioactive dating. This is what looks like to be a snail, maybe?
Yes.
Oh, it's a fossil, but
Yes,
it was
and
a
it,
snail.
and it goes through radioactive
and
dating.
it's going through the radioactive decaying process. See, it starts off as like a normal
and then it is
snail,
burned.
and then it kind of turns into a fossil.
And it's converted into carbon dioxide gas.
Right, but like it probably burned, like natural disasters.
Yeah.
Let's say it burned in a forest fire.
That sounds like a reasonable thing.
I
yes.
think it does. And then what happens? It's turned into stable C12 after the carbon dioxide.
And then unstable C14.
Oh, wow. And then the C14 decay ignites N14, emitting an electron.
Woo!
Ooh, and a proton.
Oh, and you can
a
also
nitrogen.
use a radioactive counter to record the number of electrons emitted, and you just like want to know that to just know all about radioactive dating. So that's a good thing to know.
This is all very impressive,
Yes.
but this is all the time we have today. So peace out, Miss Griffith.
Bye.
It's been real.
Yeah, we'll miss you next year.
Love you.
Bye.